So let me put us up live on the YouTube channel. So anyone who wants to look at this video later can. And then we'll get started. Okay. And then let's share this. Can you guys online see the presentation?
Yep.
Yeah.
Yes.
Yeah.
Yep.
Okay, let's get started then. So we're going to talk about why we use conduct of operations and what human performance controls do. And then we're going to talk a little bit about what a successful human performance improvement system is. So why do we have such rigid controls on behavior? I talked a little bit about this, but what do you guys think from what you know about the nuclear industry? Why do we control our operator behaviors so rigidly?
To mitigate the high risk of the job.
Okay,
The
mitigate high risk.
potential high risk of the job.
Okay, yeah, Susan.
Yeah, because it's very controversial, and we want to make sure we do it right the first time.
Very controversial. We want to do it right the first time. Public perception of risk is, I think, very skewed. And so that controversial aspect is absolutely part of it. And we can't forget that a lot of commercial power reactors are businesses. They do need you to do it right the first time because they do need to make a profit to pay their employees, right? What else? What other factors do you guys think? Okay, I agree with what you guys said. So here's an interesting alternative question. You guys are going to be very highly trained professionals. Shouldn't you be trusted to behave that way? Why do we have to make all of these controls and procedures and make you follow a written procedure step by step for something you've done probably a few years into your career hundreds of times?
I think that we're trained professionals, but at the point that we're trained professionals, it's to handle things that there's not a procedure for. If there's a procedure for it, then it would be best to follow that. But I think we would be trained to handle things that there's not a procedure for if they were to happen.
And that would seem to be a logical step, but I would actually say that you are strongly discouraged from acting where there isn't a procedure. When there isn't a procedure, you're most likely to make a decision in error, right? Because each of us are going to have a part of the plant that we know. You're going to be system experts, but you're not going to be engineers. You're not going to be quality assurance professionals. You're not going to be rad techs. So I can see why that would be your thought process, but I would actually say that that is not correct. Susan?
The consequences are really high. For, not going to, not, I mean,
Yeah, consequences are really high. So we're going to expand on that. You guys are going to be very competent when you leave this degree program and once you finish your on-the-job training wherever you get hired. We're going to make sure here that you have the fundamentals, and then your on-the-job training is going to make sure you have the specifics for where you work. So you are going to be very highly trained. However, because reactors have the capability of having extremely severe accidents, if everything goes wrong, the worst cases can be a really big deal and are highly controversial to the public, right? Fukushima has not actually caused a significant rise in cancer in Japan, but Fukushima was a big deal that changed the face of the nuclear industry in Japan, right? So regardless of what we're actually seeing as the result of that incident, as far as the data, public perception has been a huge and separate battle, right? When you are given a procedure, that is saying that you as operators and professionals, representatives from the operating group, have said that this is the right way to do this. Engineers have said this is the correct way to interact with the system and not affect other parts of the power plant. Managers have said this is something you're authorized to do. Rad techs have said if you do this, you won't get above these doses. Each step of that process across multiple different disciplines has been accounted for. And it also says that you are doing what you were instructed and authorized to do. So if there is an accident that occurs, you're also not now taking on personal liability for that decision, right? You're not doing something that wasn't authorized, that wasn't planned, that wasn't allowed because you made a decision. You are looking at the correct way to do things based on all of these groups that have different expertise and have said, this is the way we agree it should be done, and you're following that agreement, right? And so in the nuclear industry, there are actual legal precedents for how liability is paid out of reactor accidents. One example is like the Price-Anderson Amendment Act. And essentially what the government says is if you, the operator of a facility, operate it within the regulations and the way you're supposed to, your regulator, Department of Energy or Nuclear Regulatory Commission, takes some responsibility and has created a fund to help deal with accidents, right? There are some Manhattan Project era sites that are essentially Superfund. You guys heard of the EPA Superfund cleanup process? No? Okay. So before we understood environmental hazards so well, we industrially polluted the United States, like our land, a lot, right? 70s was kind of a big turnaround for that. And essentially, the Environmental Protection Agency was formed, and one of the things they did is they get a large budget from Congress to clean up places that existed and polluted before we had regulations and controls. So tanneries, right? Late 1800s, early 1900s, through the like 50s, and we had tanneries that just dumped their chemical waste into the rivers that they were located on, right? And so now we have like the Love Canal, which is out on the eastern coast, and it is one of the most contaminated waterways in the world because they just dumped. They didn't understand not to. And then once they did understand not to, it was really expensive not to, so they kept doing it. So EPA has these Superfund sites and they clean it up. Essentially, there's a similar process for cleaning up nuclear accidents that the government participates in. And one of the things that you want to kind of big picture avoid as an operator is stepping outside of those regulations that are put into place through the procedures and make sure that everyone follows them through our procedures, because you don't want to step outside that protection that we have if something goes wrong, right? So on the high scale, yes, you're trained professionals, but in order to get the protection, if an accident does occur, you have to be doing things the right way. Then on an individual level, part of your professionalism is understanding the industry you're going into is controlled that way, and your obligation is to buy into that system and use the procedures and not choose to view it as something that is a reflection of how well you know how to do what you do. It's a reflection of this is how we do it. Does that make sense? Okay. So human performance improvement uses on-the-job feedback to affirm good conduct and safety culture and operational standards, to catch mistakes or errors or violations early, and correct the human behavior aspect that led to those mistakes, errors, and violations. Because even though you guys are going to be competent operators, and I hope several of you want to take the NRC operations class in your next fall semester, your second year, and actually become licensed operators for the reactor here on campus, you're going to know how to do this well, but we're all still going to make mistakes. To err is human, right? So when you catch the behaviors that led you to these mistakes or errors, you can change your behavior so you're less error likely in how you approach a problem, right? So if you learn to remove behaviors that cause you to make errors, you're going to make less mistakes, right? It also provides data for business decisions on ineffective procedures, what our high-risk operations are, broken systems, etc. So human performance improvement is a system that requires you as operators and all the other employees to watch work happening or participate in work and give continuous feedback on how that work went. What mistakes were made, what went well, what was almost a mistake because it's a high-risk operation, but we did good behavior, so we caught our mistake, right? It has to be something that management values. And as you look in workplaces, in general, the nuclear industry is incredibly safe because all levels, employee to management to owners, buys into safety culture and human performance and safety, safety and operations. But if you end up with a manager that doesn't value continuous improvement and doing things the right way, this is not a good place to work. There are tons of places in nuclear industries that are really, really good at this. And when you're not good at this, you're not becoming a better nuclear operator, and it's going to hurt you overall, especially if you want to go somewhere else later in your career. It also has to have employee engagement. You're responsible for buying in to the safety culture at a facility. You have to be willing to do the right thing, even if sometimes that means the work doesn't get done, right? So, employees have to be dedicated to implementing consistent and correct conduct as the main role for having a successful human improvement system. Because if we're trying to control behavior, and if we're trying to say, hey, we need to ensure that this procedure, when we need to use our timer and collect data at certain intervals, we have to have two people doing this. One's the data collector, one watches the stopwatch, and then you have to both sign off that you did this. And you're like, man, that person isn't available until they finish this other job. I can go do it. I'm just going to do both at the same time, and then you get the data wrong. You didn't buy into the fact that you have to do it the way the procedure says, even if that means you have to wait and not do work until a later time, right? What the safety culture, human performance improvement, ConOps, there's a lot of operator aids that you'll find out there. And each facility will kind of have a different set of acronyms that help you remember. But one that's kind of standard across the industry is STAR. Stop, think, act, review. If you can remember in all of your future classes in this program, whenever we're talking about how we do something or the conduct of operation, if you remember to STAR, you're going to be able to apply the techniques and specific procedures we learn really well, okay? So stop, pause to focus on the task. We're going to talk about why we don't multitask in the nuclear industry, and we're going to talk about why we remove distractions. But if you pause to focus on the task, you're automatically going to get rid of a lot of those distractions and temptation to multitask, right? Okay, what are you about to do? Plan your actions. We're going to learn about pre-job briefs, and we're going to learn about initial conditions for procedures and all of the things you have to do to go through the work planning and control process at a facility. But by knowing that you need to think and plan your actions out, you're going to be able to remember that you need to participate in all of those different processes and have those different skills, right? Act. Complete the task or action as planned. If you don't use the plan you created in the think step, what good is having that step, right? We might as well just be STAR. But we have the T in there, which means that you need to remind yourself that you do the procedure as written, you do the steps as written, and you do exactly what's encompassed. And if you enter an area that's outside the procedure or you have unexpected conditions, This is no longer what you planned for. You are now outside that procedure and you need to do something different, right? You need to inform management or in some way get back into what you need to be doing in that procedure, okay? Then review. We talked about this human performance improvement system as requiring continuous feedback. This is the process. After every time you perform work, we're going to review. We're going to look at what we did right. We're going to look at what we did wrong. We're going to look at how we can improve. We're going to look for what updates the procedure needs. We're going to look at, hey, I did this, everything went fine, but I noticed that the conductivity in the water system was significantly higher at the end than I expected, and that is normal. It's still within specification, but hey, I know that conductivity in water, when it increases, that's a sign that there's corrosion. So do we need to check our other systems to see if we've got corrosion in our reactor, right? Sometimes it's getting that kind of feedback. What's really important on the review step is that you're going to be continuously asked how you did something, and it's not necessarily a reflection that anyone thinks you didn't do it right. These processes are very specifically designed to avoid blame so that you as an employee can honestly talk about what things were mistakes or errors or near misses and need to be improved. And through engaging in this process, one, as a new operator, you're going to hear older operators talk about where they still make mistakes. And so you're going to learn a tremendous amount about what you need to be focusing on as you do those same procedures and operations, right? You're also going to get a chance to get feedback from other people who were part of that job on what you did really well and where you need to improve. And so your first few years on the job, as this process happens, you're going to grow tremendously in your ability to be a competent operator at that facility, right? It's super beneficial. But even after those first few years where a lot of this information and feedback might be new, it's still going to be a continuous improvement process that continues to help you be the best operator that you're capable of by continuously showing you where you should be improving. Okay, we're going to look at a couple videos real quick, talking about buying into the safety culture process. Let me share this for those of you who are online. Okay. Can you guys see that safety culture video online?
Yeah.
Okay.
Some companies make products. Some provide services. Some have a handful of employees. Some have, well, a lot more. And you might not know it, but all companies, big or small, have a safety culture. And that's not to say all safety cultures are the same. Some are positive and effective, and some are negative and downright dangerous. Essentially, the safety culture of a company is the shared set of values and practices that guide the behavior of all employees. It's what employees do and how they act, even when nobody is watching. That's important because the two biggest causes of workplace accidents are unsafe conditions, including faulty equipment and dangerous environments, and unsafe acts by employees. In fact, 90 to 95% of all workplace accidents are caused by employees' unsafe acts, usually because they think they're doing what their supervisors want them to do. If employees are rewarded for increased productivity or meeting production deadlines, even though safety procedures were ignored, this moves the safety culture from positive to negative and potentially dangerous. Good leaders know that safety rules and equipment are critical to preventing on-the-job accidents, lost productivity, and big costs to a company's bottom line. So, to improve your company's safety culture, first make sure the top levels of management are on board. Next, create a safety committee made up of employees from all ranks of the company. Then, conduct a company-wide self-assessment of your current safety culture. This starting point will help identify what's working, what training is needed, and help the safety committee determine goals and monitor the company's progress. For trainings, remember to include not only safety and health training, but also team building and hazard recognition. And always encourage open communication throughout the process. Hold sessions with management and supervisors first, then use team meetings, regular company-wide communications, and periodic updates to train every employee and keep the momentum going. Finally, incentivize. The safety committee should create a system of accountability and recognition. Incentives for safe behavior and hazard mediation can range from a round of applause at a company meeting to company swag. At the end of the day, a positive safety culture is up to all of us. And it benefits all of us when we go home and enjoy everything a Montana lifestyle offers. For more tips on building a positive safety culture where you work, check out the many resources available at Montana State Fund.
So obviously that was specifically from Montana, but that is all the key processes that you will find at a company that has a good safety culture. And even more, there are a couple of specific programs that DOE and the NRC use to incentivize this. So something you'll see at DOE is this voluntary protection program. Okay, it's essentially it's the organization that your company would participate in that says we have implemented all those parts of safety culture and we're prioritizing safety over production, and we have our safety committee. We have engagement from management and employees. And by getting this STAR site designation, it essentially says DOE, the regulator, says, yes, this site is doing a good job. And so then there's that reward structure, right? Where now you essentially have this ability to put forth in a competitive way that we're, as a site, making sure we meet these requirements. There's a similar program for the NRC. I forget what it's called. But there's a similar designation to STAR site that commercial power companies can get that does the same thing. So it's a really big deal, and it's highly valued and it's highly pursued by the nuclear industry. We're going to watch one more video here. Oops. Okay, so this video is about questioning attitudes, and it does have some accident scenes, so that's the advisory. So if you're squeamish, just be prepared. Oh, did I share the audio? Let me share the audio. Okay. All right. Can you guys online see that video?
Yes.
Okay.
This photo was about 4 hours after I got blown up when I was just admitted into Harborview Burn Unit.
Prior to working for P&L, electrician Dan Wharton was a 25-year-old apprentice on a job in Milton Freewater, Oregon in 1998 when his life changed forever.
We were running a new 1600 amp 480 volt panel to run this facility. We already set the new panel, so we were getting ready to tie in the new chiller system into that panel. We ran about 35 feet of 4-inch conduit. We were going to push the wire into the new panel and make it up while the panel was energized. We did not use any safety equipment. The contractor didn't want to buy any. The customer did not want to turn off power because they were running their packing plant at the same time. So we decided to push a fish tape into the panel And the fish tape is a device you use to pull wire with through conduit. And the journeyman went out about 35 feet where we were pushing from, and I went into the panel. And he started pushing the fish tape, and I had my hand up underneath the conduit, and the fish tape hit my hand. I told him to stop. And when I turned my hand over to grab the fish tape jumped about 3 feet and hit a phase of neutral. By doing that, it caused an arc blast at about 15,000 degrees. Then it tried restarting 3 different times for the transformer to kick in, and then the fuse blew up on the pole. While it was trying to restart, I was on fire. I did the stop, drop, and roll, put myself out. I took off my hat and safety glasses and pulled up my contacts, which were hot. About that time, the journeyman comes in and wanted to dump water on me. Dirty, oily water, and I told him no. So he put me in the pickup truck, and we drove from Milton Free Water to Walla Walla, which is about 14 miles away. I don't know how long it took us to get there, but while in the ER, they dumped about 50 gallons worth of water on me. Took me in for x-rays and called a life flight from Harborview. And about 3 hours later, I was in Harborview burn unit.
Wharton spent 37 days over 3 visits at Harborview in Seattle. He was readmitted twice due to infection. After his burns began healing, doctors found he had torn his rotator cuff, had carpal tunnel syndrome, needed nerve relocation surgery, and had cataracts and severe tinnitus from the explosion.
I only have about 75% feeling in my hand from all of the injury, and I only have about 40% feeling in my arm.
All told, Wharton endured 2.5 years of rehab, 7 surgeries, and $70,000 of out-of-pocket expenses. He was out of work for several years because he couldn't raise his arm above shoulder height. He also suffered from PTSD with recurring nightmares.
Everybody dies and I get burned. And so I had to learn how to deal with these over the years, and now I just wake up and go, it's just a dream.
If there is a silver lining in Wharton's experience, it's the effects on his family and continuing his career as an electrician.
It brought us closer together. It made you realize what was important. It made me a better electrician. So I'm safer.
After 20 years of reflection, Wharton has words of wisdom for others who work around potentially life-changing hazards.
Follow safety rules. Ask questions all the time. Questioning attitude is the biggest one. You always need to have that questioning attitude about, is this the right thing to do? I don't want this to ever happen to anybody else. When I was 25, I was invincible. At 26, I wasn't.
When a person is young, inexperienced, or taking direction from someone with more authority, it can take courage to ask challenging questions. One of our safe conduct research principles is a questioning attitude is cultivated. This isn't just words on a page. We expect each staff member, regardless of their role, to take a personal responsibility for their safety. Ask questions, raise concerns, and don't proceed in the face of uncertainty. This becomes especially important around high hazard activities. If we are all our brothers and sisters keepers, we can go home safely at the end of each day as we perform and support world-changing science. Thanks for everything you do, and stay safe.
So I like that video because it is another DOE site. It's the very specific training that they give their onboarding employees, so new employees, to introduce how they do their human performance improvement and to get that buy-in in their safety culture. So they talk to early career people, which I think is good. So, you know, that person who was burned now works at P&L. And so he participated in creating this. And sometimes we get so focused on the nuclear hazards, we forget that you as operators will interact with electrical hazards, radiation hazards, high temperature hazards, chemical hazards, the whole spectrum, right? So as an industry, nuclear highly values safety culture and doing the right things the right way. But don't forget that this is going to apply in all of your human health and safety interactions, right? Not just the nuclear hazards. So talking about that questioning attitude and ensuring that you understand how you're protected through each step of the work you do, that you're buying into the procedures that create that safety barrier, and that you're giving feedback and ensuring that you've done that correctly. Do you guys have any questions about what that looks like in the workplace? Yeah, Susan.
What we're practicing is having somebody that's in charge of safety. Is it similar to that? Like we would go do a task and you do it together, that there's somebody that's watching out for safety, or is it more?
So a lot of times that will be used for those of you online. She asked essentially if there's somebody who comes when you're performing work and is looking out for safety, and it's like a group where there's a person who's designated to do that. And that is occasionally done, especially in very high risk operations. So, you know, as you've given feedback and you've done this human performance improvement and the company has data to identify which are the high risk procedures, there might be someone there from health and safety, or who is OSHA certified, or someone who's there to double check your lockout tag out, or your RAD PPE and barriers. But a lot of times it's up to the individual, right? Ultimately, you're responsible for your own safety and the safety of the others working with you, right? And so while that is occasionally used, a lot of times it's just, we've done the pre-job brief, we've identified the hazards, and now you guys need to go through and do this correctly to ensure those hazards are mitigated. For those of you who work maybe in agriculture, or some of you who maybe work for Simplot or some manufacturing facilities around here, do you guys think that the safety culture in your workplace is commensurate with the hazards you're exposed to? No? Susan says no. Who else?
Could you repeat like the end of the question?
Yeah. Where you currently work right now, do you think the safety culture is commensurate with the hazards you're exposed to?
No.
No? Pine does? Where do you work? Well, maybe probably shouldn't say the company name on Facebook Live, but what hazards are you exposed to that are mitigated?
Viral hazards, like including mental health hazards at a hospital.
Okay. And so they do a pretty good job. Hospitals tend to have pretty good safety culture. They deal very regularly with biohazards and have a process for that. Do you think that that experience, being part of a safety culture and mitigating hazards, you're learning things you can take forward into the nuclear industry? Yeah, I would agree. Chase, was that you online who said that you don't think your workplace is
No, it was Michael.
Michael, okay. So what hazards are you exposed to, Michael?
Walking on roofs with no safety harnesses, walking on roofs when there's snow or frost on the roof with no safety harnesses. It's not safety hazard. I think it's just stupidity.
Okay. And I'm going to guess, just based on the culture in a lot of places like that, that if you ask questions about whether or not that was the safe or correct way to do things, you would not get praised for your questioning attitude, huh?
No.
And that's the reality of a lot of industry, is that you get the job done, and if you're worried about the safety stuff, you're kind of the guy who's creating problems, right? So for those of you who work in that kind of place right now, like Michael, just be aware that you don't carry those attitudes and practices forward into your nuclear careers. Okay, that is all I had for us today, guys. We're done a little bit early. Does anyone have any questions? Okay. All right. Well, I will see you guys tomorrow. When I thought that I was going to be off campus, I had asked the second years to run your conduct of ops lab tomorrow for extra credit in their conduct of ops class. And even though I'm back, I'm still going to let them do that so they can get their extra credit because they kind of planned it. So there'll be a chance for you to meet the other cohort, and they're going to provide some training that they found beneficial that they did last year. So we will meet in the RAD mock-up area.
Will we?
If you are not able to be there, send me an email so I can give you a alternative virtual lab.
Will we need to, will we need to, or do we need to print out one of those sheets, like one of the military alphabet sheets, like the alpha beta?
So we are going to require that you use the phonetic alphabet if we have letters and numbers. So if you don't know it, it would be super helpful for you to have printed out, yes.
With that, you said when we use letters and numbers, are you saying like there's a different set, not a different set, but a way to use the numbers in a phonetic way? If that question
no, numbers will stay the same. But if we have like an identifier, like move piece 13A, you can't say 13A. You have to say 13 alpha, right? So if you don't know the phonetic alphabet, having that print out, or even saving the picture off Moodle to your phone, so you can pull it up on your phone.
Yeah.
Be helpful.
Okay. Awesome.
Okay. All right, guys. I will see you tomorrow.